Now that we have discussed inferential statistics for a single population mean when we don't know the standard deviation of the population, we can work on actually doing some calculations that will produce some results. So let's look at some applications. So first of all, you have two choices. One is to do the calculations by hand. You will still need to use the technology and the t-distribution to find the critical values. These are the t alpha halves, the z alpha halves that we needed before. So if we want to do things by hand, we will calculate the x bar and the s, so the mean and the standard deviation of the sample from the data that we have. We will find the t-score that corresponds to the confidence level, t alpha halves. You have a different distribution for every degree of freedom, for every different sample size. So you want to use your degrees of freedom to find that particular t alpha halves. Calculate the margin of error. The margin of error will be t alpha halves times the estimated standard error, which is s divided by the square root of n. And then the center of your confidence interval is your sample mean, and you will go left and right equal to the margin of error, and you will find your confidence interval. You will interpret it as, we estimate with confidence level this much percent that the true population mean, based on the context of your problem, describe it, is between the lower bound and the upper bound units that describe the mean. So we have different options, obviously, as we said. One option is to use the student's t-distribution to find percentile quantiles. So if we know the degrees of freedom, let's say we have a sample size of 20, so our degrees of freedom are 19, and we want the lower, let's say the upper tail to be half alpha halves. If our confidence level is 90, then we want the upper half to be 5% and the lower half to be 5%. We can also do two-tailed if you are confused, and then we can have our confidence level in the middle, and then we can see that instead of 1.645, that was z alpha halves for a 90% confidence level, we have 1.729 when the degrees of freedom are 19. If I had a sample size of 9 and my degrees of freedom was 8, then I will have an even wider interval, 1.86 for my t alpha halves. So you can find this t alpha halves the same way you found the z alpha halves in the normal distribution, and then just do the calculations manually and answer the question. You can use a graphing calculator, so the notes here show you how to do that if you want. We will use Excel for our projects, and actually I will use Excel now to do the math, but also there is an app in ArtofStat that does the confidence interval for you. ArtofStat does not have a confidence interval when the normal distribution is used, but it does have an app for the confidence interval when the t-distribution is used. For that, you have to scroll down to sampling distributions, and actually no, I think we have to scroll even further down. We want to go to the inference for a mean over here. And when you select that, it assumes that you don't know the population standard deviation and you have to find it. So you can enter data your own, or if the problem already gives you the summary statistics, the mean and the standard deviation of the sample, then you can enter that. But let's try to solve some examples in Excel and in ArtofStat to see how that works. It says you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects with the results given. So I need the mean and the standard deviation of this. But if I enter the data in ArtofStat, they can be separated by spaces. Then it will do it for me. So I'm going to enter my own data. It says, what's your variable? Pain level. And what are the observations? Right here, they are separated by spaces. So if you look here, it creates a histogram, it creates a box plot, it tells me what is my sample size, it tells me what is the sample mean, what is the standard deviation. What was the point estimate? The point estimate was your sample mean. What is the standard error? It was your sample standard deviation divided by the square root of 15. It calculated the product of those two values to find the margin of error. And then it told me that I am doing a confidence interval for the population parameter, which is the mean pain level. The lower bound is 7.301 and the upper bound is 9.153. And this is a confidence level at 95%. Let's see if that is what the problem was asking us. Yes, it did ask us for a 95% confidence level. ArtofStat defaults to 95%. You will have to change the percentage here if you need. So from ArtofStat, I actually have my answer, 7.301. to 9.153. And then I would interpret this by saying that, so I'm going to read the interpretation here. Remember to always use the same words. I will say I estimate at a 95% confidence level that the two population mean pain sensory rates for acupuncture is between 7.3 to 9.2 points, whatever that is, whatever it is measured in. So how will I do that in Excel? It will be part of our project. I will have to write the data out for Excel to calculate. I can calculate n as using the function count, and I will count these values. And then I will find the mean by using the function average, so equals average, and I will highlight the array of values. I will find the standard deviation. Remember, this is a sample, so not .p, but .s. I need here to make it an equal sign, not a minus sign. And then here I need the array again. I need to find the standard error. So the standard error is s divided by the square root of n. So equals s divided by the square root of, and n is located in this cell. Notice that I do not put the values by hand because I want to copy paste this and use it again. The confidence level is 0.95. 0.95. It needs, Excel needs decimals. Also, if you write 95%, it will do it for you. So I could have written 95% and it will calculate it as a decimal. And for T alpha halves, I need to use the inverse function. Remember the inverse function, you give it a probability and it gives you the t score, the variable, backwards from the regular function, the PDF or the CDF, that you give it the score and it gives you the probability. So remember that when you have your graph here and you are looking for a 95% confidence level, the 95% is to the right, in the middle, and then you have half of the remaining 4.5% here, and half of the remaining in the upper tail. And when you're going to try to find the T of alpha halves will be this one. But in Excel, when you use the inverse function needs the area below that value. So it will need this value that it will be calculated from the 95% confidence level. So how will I calculate that? I need the answer to be the sum of this 95% and this 2.5%. But I don't want to enter this manually. I want the value to be adjustable if I want to change my confidence level. So if I wanted to change my confidence level to 90%, I would like Excel to automatically add 90% plus half of the remaining. So what I'm going to do is I'm going to say that this sum in the general case is the confidence level probability plus the one half of 1 minus the confidence level, which is the alpha. So I want confidence level plus half of alpha to be on the left, and I need half of alpha to be on the right. So that's what I'm going to do. And to use that again, we will use the inverse function. So there is if you press equal t, it will give you all the t distribution functions that it has. T dot inverse is the function that if you give it the probability on the left tail and the degrees of freedom, it will give you the t-score. So the probability on the left tail is equal to this 95% plus the alpha, and alpha halves, I should say. So alpha is 1 minus the 95%, that's the alpha, and then divide by 2. So that is my probability, and then comma, after that it says degrees of freedom, and if you remember, degrees of freedom is n minus 1. So if I do that, I found the t alpha halves. This t alpha halves 2.14 is this t-score, and let's do here an error bound for the mean. The error bound for the mean will equal to t alpha halves times the standard error, which is this, s square root of n. And after we do that, the interval will be lower bound equals to point estimate, which is your mean, minus the error bound. And here equals the point estimate, which is your mean plus the error bound. And this is 7.3 to 9.15. And this is approximately what we found here, 7.3 to 9.15. In fact, if I were to round to the nearest 3 decimal digits, let's do that. We will have Excel round for us. It will round to the values that Art of Stat gave us. So Excel can do a better rounding. So that's how we would find in Excel, and it is part of your project to do that. So we did it in Excel. We found n. For your notes, if you are filling the notes out, please fill this out by what the video did when you submit your notes. Let's try another problem, and again we will try it in both places. The nice thing about Excel now is that if you have coded it once, you don't need to code it again. So you do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get each night. You measure hours of sleep of 12 subjects with the following results. Construct a 95% confidence interval for the mean number of hours slept for the population, assumed normal, from which you took the data. So if I take this data and I go in Art of Stat, and these are sleep hours, and the confidence level is still 95. It will tell me that the sample size is indeed 12, the mean was 8.983, the standard deviation is 1.290, the point estimate is the sample mean, the standard error was the standard deviation divided by the square root of 12, and the margin of error was the product of those two. The interval happens to be 8.163 to 9.803. So 8.163 to 9.803. We will interpret it in a minute, but let me show you how, if you now have already done this work, you can just take all of this and copy it here, and it will automatically calculate everything for you. So I do have an interval 8.163 to 9.803, which is exactly what ArtofStat found. I did find an n equal to 12. I did find a mean of 8.983. Same thing. I did find a sample standard deviation of 1.290. I did find the standard error to be 0.372509. This is the 0.373 over here. I did find a margin of error of 0.82. Let's check it out. Here it was, 0.82 is my error bound. And then I did find the correct interval, and I didn't have to recode all of these things because I have already coded them. So let's interpret the interval. Remember to reference number 5 here in your notes to write an interpretation as a complete sentence in English. Pause the video and see if you have written the same thing as I will write here. So our conclusion or interpretation of the confidence interval is that we estimate with 95% confidence that the true population mean number of hours sleep subjects get at night is between 8.16 hours and 9.80 hours. Let's refresh our memory on the glossary for this section. We talked about what degrees of freedom are. And we also talked about a new distribution that we will be using called the student's t-distribution and its properties. I also want to remind you that in this second half of the course in statistics, we are learning how to do inferential statistics, also called statistical inference or inductive statistics, and it deals with you estimating a population parameter based on a sample statistic. So based on a mean that you have found, you of a sample, which is approximately 8.2 hours, you estimate at a certain level of confidence that the true population mean, the 8.2 was points of pain, the true population mean pain level will be between 7.3 and 9.2. For this reason, when you are in the ArtofStat apps, you are now using apps that refer to the statistics you will be conducting, which is inference for a mean. So you are inferring some conclusions for a population mean that you don't know based on sample data that you collected.